Jai Hind children, welcome to today's class. Today we are going to continue with the chapter Limits and Derivatives. The new topic derivative and some basic derivable functions we are going to study in this section. What is derivative? In physics you studied about dy by dx, dy by dt, dx by dt, etc. Basically, we can say derivative as the change in one quantity with respect to another. You may study it as the rate of change of one quantity with respect to another. For example, consider a circle having a radius r. You know, the area of the circle can be found out by the formula a equal to pi r square. If the radius increases, correspondingly the area of the circle also increases. And if the radius decreases, the area of the circle decreases. In this case, you can say that the change in area with respect to the radius. The change in area with respect to radius. This can be represented as dA by dr. Means that the rate of change of area with respect to the radius. So, derivative of a function at a point A can be defined as, suppose f is a real valued function and A is a point in its domain. The derivative of the function at the point A, if you want to find the derivative of the function at the point A, it is usually represented as f dash A. F dash means the derivative at the point A. A is the point given here. To find the derivative at the point A, you need to consider one more point A plus h, which is very close to A, where h is negligibly small. The definition states that f dash A equals limit h tends to 0, f of A plus h minus f of A divided by h. Means that f of A plus h means the value of the function at the point A plus h minus value of the function at the point A divided by the difference between them is h. So this is the definition of the derivative of function at a point A. Let us discuss a problem. Find the derivative at x equal to 2 of the function fx equal to 3x. You are given with a function as fx equal to 3x. The given function is fx equals 3x. You need to find the derivative at x equal to 2. So, in the definition you studied the derivative of a function at a point A. Here, your A is given as 2. So, you need to find the derivative of the function at the point 2. So, the definition states that f dash of 2 you need to find. You know the basic definition as f dash of A equals limit h tends to 0 f of A plus h minus f of A divided by h. Here the value of A is 2. You need to find the derivative at the point 2. So f dash of 2 equals limit h tends to 0 f of, replace the A plus h with 2 plus h as the value of A in this question is 2 minus f of 2, replace A with 2. You need to find the derivative at the point 2 divided by h. Okay, we can find that you are given with the function as fx equals 3x. Can you say what about f of 2 plus h? F of 2 plus h means that replace the x in the function with a 2 plus h. So, okay, we can replace x 3 into 2 plus h. F of x equal to 3x, but f of x equal to 3 into x. So, f of 2 plus h equals 3 into 2 plus h. So, replace the x with the 2 plus h in the question. So, I am going to substitute the value here equals limit h tends to 0. F of 2 plus h can be replaced with a 3 into 2 plus h minus f of 2. What is f of 2? Here, fx equal to 3x. So, f of 2 equals, replace the x with 2. 3 into 2. 3 into 2 is 6. So, that we can write here as 3 into 2 divided by h. Okay, we can substitute the value which is equal to limit h tends to 0. 3 into 2, 6 plus 3h minus 6 divided by h. You can see that the plus 6 minus 6 get cancelled. The remaining is limit h tends to 0, 3h by h. Don't substitute the value for h at 0 now because it will become an indeterminate form. Again, make a cancellation. At last, you can see that limit h tends to 0, 3 is a constant. So, the value of the constant limit is that constant itself 3. So, the answer is limit derivative of fx equal to 3x is 3. Derivative of, therefore, derivative of 3x obtained to as 3 is the answer. Very important. Consider another question. Find the derivative of fx equal to 4x plus 5 at x equal to 3. Your function is 4x plus 5. Given fx equal to 4x plus 5. At x equal to 3, here the value of a equal to 3. Okay, we can take the definition at first. We have f dash of a equals limit h tends to 0, f of a plus h minus f of a divided by h. Okay, we can substitute the value here. Therefore, f dash of 3 you need to find. You are asked to find the derivative of the function at 3. So, f dash of 3 you need to find equals limit h tends to 0. Replace the a in the definition with a 3. So, f of 3 plus h minus f of 3 divided by h. Now we can see what is f of 3 plus h. fx is given as 4x plus 5. f of 3 plus h can be taken as replace the x with the 3 plus h. So 4 into 3 plus h plus 5. This I am going to substitute here. Limit h tends to 0. f of 3 plus h can be replaced as 4 into 3 plus h plus 5 minus f of 3. I need to find the value of f of 3. f of 3 means replace the x with the 3. So 4 into 3 plus 5. This I am going to write here minus of 4 into 3 plus 5 the whole divided by h, which is equal to limit h tends to 0. Okay, we can multiply inwards. 4 into 3, 12 plus 4h plus 5 minus 4 into 3, 12 minus 5. Minus 12 minus 5. The whole divided by h. Now you can see that plus 12 minus 12 get cancelled. Plus 5 minus 5 get cancelled. The remaining is limit h tends to 0. h tends to 0. 4h by h. Don't substitute the value for h at 0 now. Again h get cancelled. The remaining is limit h tends to 0, 4. Limit h tends to 0, 4. 4 is a constant value. So the value of the limit is 4h. Therefore, the answer or derivative of fx equal to 4x plus 5 equal to 4. Now we are going to study about the core of the derivative, the basic concept in derivative, the first principle. Very important one. First principle of derivative. Suppose f is a real valued function. The derivative of f at any point x. You studied at any point a. Here x is a general point in the domain of the function. Then it is defined to be the basic definition just like this. F dash x equals limit h tends to 0, f of x plus h minus f of x divided by h. This is the basic function or basic formula for to find the derivative of a function at any point x. Usually derivatives can be denoted by dy by dx or f dash x or capital D of fx. That is, we can read it as derivative of the function fx. Now we can study about the algebra of derivative functions. Listen to this. If fx and gx be any two functions, then derivative of fx plus gx. Fx plus gx means the derivative of the sum of two functions equals derivative of the first function plus the derivative of the second function. That is derivative of, we can simply write like this, derivative of f plus g. If you consider two functions as f and g, f plus g can be written as derivative of f plus derivative of g. In the same way, derivative of fx minus gx can be written as derivative of fx minus derivative of gx. Or in short, we can write as d by dx of f minus g equals d by dx of f minus d by dx of g. That is, the derivative of difference of two functions equals difference of their derivative. So these are the two formula for to find the sum and difference of the derivative function. For to find the derivative of fx into g, you may think that it can be written as derivative of fx into derivative of gx. But that is not true. So remember that derivative of fx into gx is not equal to derivative of fx into derivative of gx. Now we think how we can find the derivative of product of two functions. We need to use another rule that we call as the Leibniz rule. Now we can study the derivative of product of two functions. That is what we call as the Leibniz rule. Derivative of product of two functions fx into gx can be found out as equal to the first function fx into derivative of the second function gx. First function fx into derivative of second plus the second function gx into derivative of first. This we can call as the first function. This is the first function and this is the second function. The first function into derivative of second plus the second function into derivative of first. This we can think shortly. Or derivative of u into v. If you can think of two functions u and v, u is the first function for u, v is the second function for u. Derivative of u into v equals first function into derivative of second is v plus second function into derivative of first. So basically we can think the derivative of product of two functions, first function into second function. If the product of two functions is given for you, remember like this: first function into derivative of second plus the second function into derivative of first. A very important rule. In the same way, we can study a rule for finding the quotient of two functions. Derivative of quotient of two functions d by dx of fx by gx equals gx into d by dx of fx minus fx into d by dx of gx, the whole divided by gx square. This is the formula for to find the derivative of quotient of two functions. That is, if you think this as the numerator and if you think this as the denominator, derivative of numerator by denominator equals denominator into derivative of numerator minus, in the case of quotient rule there comes with a minus, and in case of the product rule there comes with a plus in between. So denominator into derivative of numerator minus, what is the fx? The fx is numerator. Numerator into derivative of gx. Gx is denominator. The whole divided by this gx is denominator square. So we can think as the derivative of the quotient of two functions with a numerator and denominator can be rewritten as denominator into derivative of numerator minus numerator into derivative of denominator, the whole divided by denominator square. You can think like this also. So again, once again, the derivative product and quotient of two functions, apply these two rules. D by dx of, or derivative of first function into second function equal to first function into derivative second plus second into derivative first. Denominator of derivative of numerator by denominator equals quotient rule. Denominator into derivative numerator minus numerator into derivative denominator, the whole divided by denominator square. So you need to by heart these two rules, very, very important. Now we are going to do problems based on derivative of a function. Find the derivative of fx equal to a, where a is a constant. What is the derivative of a constant function that we are going to study? Whenever you are asked to find the derivative of a function, apply first principle. The basic definition is, for to find the derivative of a function fx, that is f dash x, can be found out by using the formula limit s tends to 0 f of x plus h minus f of x divided by h. This is the formula, or this is the first principle for to find the derivative of a function. Here the function fx equal to a. We can find, therefore, f dash x equal to, here you need to find the derivative f dash x equals limit s tends to 0 f of x plus h. Fx equal to a. So f of x plus h means replace the x with the x plus h. But as there is no variable x on the right side, you can replace it with a only. So f of x plus h is a minus f of x. F of x is the original function a divided by h equals limit s tends to 0. A minus a is 0. 0 by h. 0 by any number is 0. Therefore, derivative of the constant function a equal to 0. From this we can study one result, that derivative of a constant function, if the function is a constant one, then its derivative is 0. A very important result. Derivative of constant is 0. Important. Now we can see what about the derivative of a linear function. Find the derivative of fx equal to 10x. Here 10x is a linear function. The basic definition we can apply at first. F dash x equals limit s tends to 0 f of x plus h minus f of x divided by h. But in this case the function is given to us 10x. Okay, we can see what about the derivative f dash x equals limit s tends to 0 f of x plus h. Fx equal to 10x. So f of x plus h equals, replace the x with the x plus h. On the right side, replace the x with x plus h. So 10 into x plus h. Replace it with 10 into x plus h minus fx. Fx is the original function 10x, the whole divided by h. Okay, we can simplify this equals limit s tends to 0. This we can multiply inwards 10x plus 10h minus 10x, the whole divided by h. Here plus 10x minus 10x get cancelled. The remaining is limit s tends to 0. Limit s tends to 0. The remaining is 10h only. So this 10h divided by h. Don't substitute the value of h as 0 now. It will become an indeterminate form. So cancel the h again. Then limit h tends to 0, 10 will come. Limit h tends to 0, 10. You know that you can't apply the value of h as 0 here, as it is a constant. The limit of a constant function is that value itself 10. From this you can say that, therefore, derivative of 10x equals 10. From this you can arrive at the result that derivative of a linear function, that is if it is 4x plus 5 or 10x plus 2, whatever it may be, derivative of a linear function gives, if it is a linear function, then its answer will be the coefficient of x. Coefficient of x. A very important result. Derivative of a linear function always gives the coefficient of the variable x. Next question. Find the derivative of fx equal to x square. Here, x square is a quadratic function. We can study what about the derivative of a quadratic function. The basic definition is of dash x equals a limit s tends to 0 f of x plus h minus f of x divided by h. Here, the function given to you is fx equal to x square. What happens when, okay, we can apply the definition at first. Therefore, f dash x equals a limit s tends to 0 f of x plus h. F of x plus h means here fx equal to x square. So, f of x plus h means replace the variable x on the right side with the x plus h. So, x plus h the whole square. Replace the variable x with the x. Replace the variable x with the x plus h in the second term. So, x plus h the whole square will come. So, limit s tends to 0 f of x plus h can be written as x plus h the whole square minus fx is the given function, that is x square the whole divided by h. A very important question. Equals limit s tends to 0. This you can expand using a plus b the whole square only. What is a plus b the whole square? A square plus 2ab 2xh plus b square is h square. This is a plus b the whole square minus an x square there with the whole divided by h. Now think about the cancellation. Here plus x square cancel with the minus h square. The remaining is limit s tends to 0. Limit s tends to 0. The remaining terms are 2xh plus h square divided by h. Now what I am going to do that, if you substitute with the value of h as 0 now, it becomes an indeterminate form. So from these two terms I am going to take an h common outside. So when taking h common outside, the remaining becomes 2x on the first term plus from the h square 1h common outside to the remaining is an h the whole divided by h. So that plus h get cancelled. We can write the remaining terms equal. This step seems to be very important. Limit h tends to 0 2x plus h. No simplification further. So we need to substitute with the value for h as 0. Limit h tends to 0. Substitute the value for h as 0. So the answer will be equal to 2x plus 0, which is 2x. Therefore, from this we can conclude that derivative of x square equal to 2x. Derivative of the quadratic function x square equal to 2x. By heart this. Derivative x square equal to 2x. Come with another function. How to find the derivative of fx equal to 1 by x, the reciprocal function 1 by x. Okay, at first we can write the basic definition. We have f dash x equals limit s tends to 0 f of x plus h minus fx divided by h. This is the basic definition. Here, in this question, the function fx is given to us 1 by x. Now we can apply the definition equals f dash x equals limit s tends to 0, limit s tends to 0, f of x plus h. Fx equal to 1 by x. So f of x plus h means that on the right side replace the x with the 1 by x plus h. Fx equal to 1 by x. So on the right side you need to replace the x with the x plus h. So 1 by x plus h will come. So limit h tends to 0. F of x plus h can be replaced with 1 by x plus h minus fx is the original function 1 by x the whole divided by h. Now listen to the simplification equals limit s tends to 0. On the numerator I am going to take the LCM as x plus h into x. Numerator LCM x plus h into x. So here comes with an x minus, here comes with a x plus h. Don't forget to put the bracket. The whole divided by this much single function. The whole divided by this numerator is simplified here. The whole divided by the denominator h there with h. So this much. Now I am going to make a simplification equals limit h tends to 0. Removing the bracket x minus h divided by x plus h into x. Remember, this we can think as a by b, the whole divided by ac there. But you know how to divide two fractions. Take the reciprocal and multiply, it becomes a by bc. So this denominator c will come here. So x plus h into x into an x will come in the denominator itself. Again, we can cancel plus x minus x get cancelled. The remaining is limit h tends to 0. Limit h tends to 0. The numerator there is a minus h divided by, in the denominator all are products, x plus h into x into h. Again h get cancelled. The remaining is equals limit h tends to 0. In the numerator there is only 1 minus 1 divided by the denominator remains with the x plus h into x. No further simplification, so we can apply with the value for h at 0 here, which is equal to minus 1 by, I am going to apply the value for h at 0, so minus 1 by x plus 0 into x equals minus 1 by x into x, that is x square. Very important. So derivative of the function, therefore derivative of the function 1 by x, you are studying about the reciprocal function. Derivative of the function 1 by x equal to minus 1 by x square. Very important. Thus we studied derivative of a constant function is 0. Derivative of a linear function equal to coefficient of x. Derivative of the quadratic polynomial h square equal to 2x. Derivative of the reciprocal function 1 by x equals minus 1 by x square. Now we are going to study an important theorem. Now I need to study the proof of the same. Derivative of fx equals x raised to n is n into x raised to n minus 1 for any positive integer n. Means that if a function fx is x raised to a positive power, positive integer power, then the answer will be derivative of x raised to n equals the power n into x raised to the power minus 1. This will be the derivative of x raised to n. For example, if you want to find the derivative of x raised to 100, the answer will be power 100 into x raised to power minus 1. Power is 100. 100 minus 1. So the answer is 100 x raised to 99. The same way, derivative of x cube equals the power 3 into x raised to power minus 1, 2, 3x square. So derivative of x cube equals 3h square. Derivative of 1 by x square. 1 by x square you can think as x raised to minus 2. 1 by x square can be think as x raised to minus 2. Now again applying the rule you get the power minus 2 into x raised to power minus 1, power minus 1. So the answer is minus 2 x raised to minus 3. This minus 2 x raised to minus 3 we can write as minus 2 x raised to minus 3 can be written as 1 by h cube. So this formula is used for any power n, even if it is positive or negative. So derivative of any number raised to a power or any variable raised to a power, the answer will be the power into x raised to power minus 1. Now, based on this result, we are going to prove this. Find the derivative of fx equals x raised to 100 by 100 plus x raised to 99 by 99 plus etc. plus h square plus x plus 1. This function derivative you need to find it first, and also you need to prove this result. f dash 1 equals 100 into f dash 0. At first we can find the derivative of the given function. F dash x equals, the given function is this one, f dash x equals, I am going to apply the rule. At first x raised to 100, what is the derivative of x raised to 100? 100 into x raised to 100 minus 1, that is 99, the whole divided by 100 there. You study that the derivative of the sum of functions can be found out as the derivative of the sum of each function. So it is equivalent to derivative of x raised to 100 plus 100 by 100, derivative of the second term, etc. plus derivative of this term, derivative of this term plus derivative of the last term. So in this way you can split up 4 to find the derivative. Why? Because derivative of the sum of two functions, so derivative of f plus g can be written as derivative of f plus derivative of g. This is studied. Based on that we are going to split up. So first is x raised to 100 derivative, that is 100x raised to 99 by 100 plus x raised to 99, its derivative is 99 power into x raised to power minus 1 divided by 99 plus etc. plus here comes with x raised to 2, the power 2 into x raised to power minus 1 by 2 plus here comes with the x if you want you can think as x raised to 1. So the power 1 into x raised to power minus 1, 0, or otherwise you can think this as a linear function. Derivative is for a linear function. What about the derivative? Derivative is the coefficient of the variable x, that is 1. That way also we can find. Plus the last one is 1, that is a constant. We study that derivative of a constant is 0. So 1 is a constant, so its derivative is 0. Now I am going to simplify. This 100 get cancelled, 99 get cancelled, 2 get cancelled. So the remaining is f dash x equals x raised to 99 plus x raised to 98 plus etc. plus x raised to 1, that is x, plus x raised to 0, x raised to 0 is 1, the last term is 0. This is f dash x. Now you are asked to prove this result. So I am going to prove it as f dash 1. Find f dash 1 equals, what is f dash 1? F dash x is this one. So f dash 1 is, you need to replace the x with 1. So 1 raised to 99, that is 1, plus 1 raised to 98, that is 1, plus etc. plus 1 plus 1. How many times? This much 99 times plus 1. So total 100 ones are there. 100 times ones are there. So the answer will be 100. This is f dash 1. Now we can find 100 into, this is the LHS f dash 1. Now I am going to find the RHS. RHS is 100 into f dash 0. 100 into f dash 0 equals 100 into, what is f dash 0? F dash x is this one. F dash 0 means 0, 0 raised to 99, that is 0, plus 0 raised to 98, 0, plus etc. plus here 0, plus the last term is 1. F dash 0 means replace all the x with 0. So the answer is, the last term here is 1. So the answer is 0 plus 1 is 1. So 100 into 1 is 100. Thus LHS equals RHS. A very good question. Now we can study how to find the derivative of sin x. Sin x is the trigonometric function. The derivative can be found out by using the first principle, f dash x equals limit h tends to 0, f of x plus h minus f of x by x. Here your given function fx equal to sin x. Then f of x plus h becomes equal to sin, right side replace x with the x plus h. When left side you replace with x plus h, right side also replace with x plus h. Okay, we can find that. Let the given function be, let fx equal to sin x. We have f dash x equals limit h tends to 0, f of x plus h. What is f of x plus h? Sin of x plus h minus f of x. F of x is the original function sin x, the whole divided by h, which is equal to limit h tends to 0. This is of the form sin a minus sin b. What is the formula for sin a minus sin b? The trigonometric formula 2 cos a plus b by 2 into sin a minus b by 2. This formula I am going to apply here. So, limit h tends to 0, 2 cos a plus b by 2, a plus b by 2, your a is x plus h and b is x, into sin a minus b by 2, a minus b by 2. This is the numerator alone. The whole divided by an h remains there. And next step I am going to make an arrangement here with limit h tends to 0. This cos x plus h plus x, that is cos 2x plus h by 2 into sin plus x minus x get cancelled, the remaining is h by 2, the whole divided by, here an h, this 2 when comes to the denominator becomes h by 2. Why? Because taking the reciprocal and multiplying, this 2 when comes to the denominator becomes h by 2. This we can arrange as again a formula there with limit h tends to 0 fx into gx can be written as limit h tends to 0 fx, separating the limit into the limit h tends to 0 gx. We can give the limit separately. So in the same way, I am going to separate this as equal to limit h tends to 0. This I am going to separate as cos 2x plus h by 2 into limit h tends to 0. This much I am going to group together. Sin h by 2 divided by h by 2. This I am going to group together. Sin h by 2 divided by h by 2. Here, when applying h at 0, here when applying the limit as h tends to 0, no simplification further. So, you can apply the limit as h tends to 0. You get cos 2x plus 0 by 2 when h becomes equal to 0. Here, in this case, limit theta tends to 0, sin theta by theta is 1. The same h by 2 comes here as h by 2, but here h only. But, so in this case, you know that as h tends to 0, h by 2 tends to 0 by 2, which is 0. So, no problem for this h tends to 0. This, the standard limit h tends to 0, sin h by h equal to 1. So, this we can substitute with 1. Now, cos 2x by 2 is, which implies cos 2x by 2 is cos x into 1, which is cos x. From this, we studied the standard derivative as derivative of the function sin x will be equal to cos x. Very important question. How to find the derivative of sin x using first principle. Derivative of sin x equal to cos x. Let us see how to find the derivative of tan x. We can study the derivative of tan x. Given function is fx equal to, given fx equal to tan x. You know the standard formula as f dash x equals limit h tends to 0, f of x plus h minus f of x divided by h. This is the formula for first principle. Equals limit h tends to 0, f of x equal to tan x. F of x plus h means replace the right side with x plus h, x with x plus h, minus f of x is the original function tan x, the whole divided by h. Now, listen to the simplification. Equals limit h tends to 0. Here, I am going to keep this 1 by h side and inside the bracket tan x plus h minus tan x I am going to simplify, which is equal to limit h tends to 0, 1 by h into this tan can be replaced as sin x plus h by cos x plus h, because sin by cos is tan, minus here this tan can be replaced with a sin x by cos x. Applying formula for tan equal to sin by cos. Now limit h tends to 0, 1 by h outside. Inside the bracket I am going to take the LCM as cos x plus h into cos x, the LCM. Here comes with a cos sin x plus h into cos x. Sin x plus h into cos x minus here cos x plus h into sin x, cross multiplying cos x plus h into sin x. The whole divided by cos x plus h into cos x. Now within the bracket the numerator is of the form limit h tends to 0, 1 by h into, look at the numerator. The numerator is of the form sin a cos b minus cos a sin b. What is the formula for sin a minus b? Sin a minus b equals sin a cos b minus cos a sin b. So which is of the same form. Therefore we can apply that formula sin a minus b. What is your a? A is x plus h minus b equal to minus b is x. Sin a minus b. A is x plus h minus b is x. The whole divided by, this is the numerator learn, the whole divided by the denominator is cos x plus h into cos x. This we can simplify as equal to limit h tends to 0, 1 by h outside into, within the bracket x and minus x get cancelled. The remaining is on the numerator a sin h alone divided by the denominator is cos x plus h into cos x. Listen to the arrangement now, which is equal to limit h tends to 0, 1 by h into, this step I am going to write again, sin h divided by cos x plus h into cos x. This is the last step. Equals, I am going to make an arrangement as limit h tends to 0. This sin h by h can make it in one bracket for to make the limit as 0. Sin h on the numerator divided by h in the denominator into, again the separate limit there with limit h tends to 0, 1 by, what remains there, 1 by cos of x plus h into cos x only remains there. You need to split up as two different functions, 1 by h into sin h one function and 1 by cos x, h plus h into cos x the other function. Give the limit separately. This you know that sin h, the same h here, that h tends to 0, therefore the limit is 1 for the first one. And in the second case, no standard limit, so instead no simplification further, we can substitute with the value of h as 0. When h becomes equal to 0, cos x plus 0 will come to the first bracket into the next bracket is cos x itself. So the answer is equal to 1 into 1, the numerator is 1 by cos x into cos x, that is cos square x. What is 1 by cos square x? 6 square x. Therefore, the derivative of, very important, the derivative of tan x. Derivative of tan x equal to 6 square x. Now let us recall the points which we discussed here with derivatives, which are the points you need to keep in memory, the basic concepts. F dash a is how to find the derivative at a point a. Limit h tends to 0, f of a plus h minus f of a by h. But the first principle states that f dash x is, that is derivative at any point x equal to limit h tends to 0, f of x plus h minus f of x divided by h. Next we study that the derivative of a constant function is 0. Derivative of x, that is a linear function, then you need to write the coefficient of x, that is 1. Derivative of x raised to n, the power n into x raised to power minus 1. Derivative of 1 by x is minus 1 by x square. Derivative of sin x is cos x. Derivative of tan x is sec square x. You need to by heart all this. Then product rule. Derivative of the product of two functions u and v. U take as first function, v take as the second function. First function into derivative of second plus second function v into derivative of first term. Then quotient rule states that the derivative of the quotient of two functions. This you can think as the numerator, this as the denominator. So denominator v into derivative of numerator u minus numerator u into derivative denominator the whole divided by denominator square.